So today we're looking at how changes to equilibrium do things to our graphs. So we'll start with adding or removing our products or reactants. So if we're adding a product or if we're adding a reactant, really a lot of these we're going to want to be removing a reactant because that's why we're doing it. And eventually hopefully you'll be able to look at the graphs and be able to figure out what's happening. So I'll provide some examples. I think you should try and watch some of the Khan Academy ones where they're much better at doing this than I am. They've got the online things. So I'm going to throw some questions at you, some VC questions, and you can kind of look there, look at the answers. I'll do some of the answers as we go along. I think you're going to be okay with this. It's just getting your head around because it seems it's very different to some of the other stuff we've done. And I think you're all right, most of you, but okay. All right, so if I add my product, so I've got my equilibrium equation here. I've got P for product, R for reactants. So add some products. Well, what's going to happen to my concentration of products at that point of equilibrium? So add exactly the point I add it. This is going to go up. But my reactants, nothing's going to happen initially. So at that point of equilibrium, there's going to be no change at the beginning. So unless it's a very, very speedy reaction, there's going to be no immediate change, but then it's going to increase because I've got more of my product to be used up. So my reactant is going to go up. And then my equilibrium is going to be shifting. I know this is terrible arrows and stuff. To the left. So that equilibrium is shifting to make more reactants because I've got more products to do up. I've got my adding reactants. So I'm adding my reactants. I don't know why I would want to do that. But I'm adding some reactants. So initially this is going to go up because I've just added some. I've pumped some into my vessel or whatever. And then I've got the same happening here. I've got no change initially, like at that point happening to my products because they've only just been added. But then eventually it's going to go up because I've got more reactants, so the equilibrium's being shifted to this way. So that is a very simple way of kind of to think about it. It's a good, some of these little summary things, and you'll find them online and all these kind of things are really good kind of snapshots to help you when you're revising to look at, rather than just a whole slab of text and a whole load of things. That's why I wanted you to do that annotated graph, but we'll do the graphs together now. Remember, I'm terrible at drawing graphs. So I'm just going to ask you to sketch them. We'll have a look at some of the actual questions, but I don't know if they really are going to want you to spend all your life drawing a graph. That's what the Prac investigation and SACs are for, rather than the exam. So I've color coded this. I've got my concentration on this, and I've got my time on this. So I'm doing this experiment. I've got hydrogen gas, iodine gas, and iodine, and I get hydrogen iodide gas. So homozygous, they're all in the same state, so I don't have to worry about the fact that there's some weird and wonderful ones because they're just all in this big vessel doing their thing. So I've got at equilibrium, I've got some concentration. So you haven't been given it, you might be given a rough idea of how much you've got. We'll just go with some amount. I don't have the question yet. Yeah, the question doesn't appear to have to give it to you. They just say this is the thing. Right, so we'll start with my iodine. Let's put that here. And I'm sure that should probably have a state, but you know, let's go. I've got my hydrogen, and I should put that down here. Is 2. I would try and make sure you draw your graphs quite big, kind of spread out. I would not use pen in an exam because things like this happen and you can't have whiteout, so I would use grey lead. If you're worried, if you're one of the people who writes quite lightly, just make sure you get used to writing hard, because remember they're scanning your exams and then looking at them on a screen. So if you have like light handwriting, it might not come through as clearly as you want. You just have to, you know, do this thing. So product, reactant, and my products down here. So at equilibrium, they've reached this state. I've got my iodine, hydrogen, and my product, hydrogen iodide. So my 3 things. So what I'm going to do is I'm going to add some of one of my reactants. So decided that this isn't good enough. I want to add some more hydrogen because it's quite cheap, and a new delivery's come in. I don't know why I'm doing it all of a sudden, but I've added some more hydrogen. So let's try and make the time about the same. So let's say this is whatever time, 20 minutes into the reaction, whatever it is. So I all of a sudden pump some more hydrogen in. The concentration straight away is going to increase up here because I've just dumped a load more in. It's like I've all of a sudden dumped a load of students in to my classroom. This is all of a sudden going to shoot up. What's now going to happen is it's probably easiest to think about what's going to happen to this. So I've all of a sudden got some more of here, my hydrogen gas, more of my reactant. So my product is going to increase, but it's not going to increase quite so quickly because it hasn't all of a sudden been thrown in. We need to have those collisions happening. Just because there's a higher concentration of the gas, it doesn't mean that's what's going to happen. So we'll see a slow increase and a shift in the position of our equilibrium. So we've got, it comes in and then slowly it's going to react with my it's slowly reacting with the iodine gas, and then that's my new position of equilibrium. Higher than here because I've got a higher concentration, because I've got more of those reactions able to happen because there's more hydrogen there. So because this is being used up and this one's being used up, so I've got more of this one and this one's being used up, they're going to go down. So they're going to move down and we're going to get a shift. So this hydrogen's being used up and it's kind of going to maybe like that. A little wonky. So it's going to decrease. It's kind of at the same rate. Yeah. I mean, not as pretty, but it's going to decrease at the same rate and reach this new point. So it's still a higher point of equilibrium than it was. It's just shifting down. So if this is going down like this, it's going to need something to be reacting with. It's not going to just reacting with anything, and it's going to be reacting with this iodine and shift us down like that ish. Not beautiful, not great, but I think that's showing you what we need to do. So we've had an influx of hydrogen, and you can see it's coming really quickly because you've just got that big spike. So it's just someone's turned a tap, let a load in, and that's how you can identify which one is being changed. So because we've got more of it, we've got that increase here, and these two are being used up, so they're decreasing, and we've got that shift in that position of that equilibrium. And then what time would that be? I think it's about here. So that's the time when our new equilibrium is being established. And I've got a net forward, so increase in HI. What else do I need to have labelled on there? Oh. Well, these two are decreasing. Being consumed. I don't have to talk when I write, but it helps. That line here is my equilibrium. Re-established. And let's have that one there. In of H2. Right, so that's the kind of thing I'm going to see. I'm going to try quickly. I need to have some lunch, otherwise I'm going to go mad. Right, watch your space. I'm going to try and do the changing the volume and the pressure. And then I'm going to look at putting inner gases in there, and then our temperature changes. So yeah, that's what that is. So have fun. See you soon.